Hey, Programming 12. We're going to take a look at how do we make the mouse sort of wrap around so that we can endlessly scroll to the left or to the right, and we just keep spinning in 360 degrees. I'm going to warn you right now that this code is not perfect. It's buggy, at least in terms of, like, it doesn't cause crashes or anything, but it does have like a rather annoying moment where there's a bit of a jump or glitch that happens at the moment when we turn. And I know this isn't the way Minecraft does it. Like they kind of keep the mouse centered, but I haven't figured out how to do that yet. So I know how to center the mouse. I just don't know how to measure the changes using sort of the built-in processing stuff. So I don't know. We'll have to figure that out. Might have to abandon PMouseX and altogether and make our own, but I don't really want to do that. We want to kind of focus on the new stuff, and I don't know. We'll just roll forward with this system, and that'll let you move on to the next set of videos. But you know what? Like it's going to be good no matter what. I think you'll enjoy it. So if nothing else, you'll learn how to automate the mouse, and you can make cool bots for clicking on things and stuff for your computer with processing if you wanted to. So anyways, here we go. Here is the deal. We're going to import this class called the robot class. Again, it's designed for writing Java programs that automate key presses and mouse clicks and mouse movement. So we'll be able to control the mouse with it. I'll make a robot object here. This is all above setup, right? At the top is a global variable. I called it RBT. I don't know. I didn't have much creativity, unfortunately. My robot could have been your name. Whatever you want to call it. It's up to you. But it is a robot object. And you can Google the robot class if you want to learn all the cool things it can do. There's an API page that tells you all the methods or functions, whatever you want to call them, that you can use. So feel free to investigate more. So what I'm also going to have to do is I'm going to have to make the size of the screen the full size of the screen. Wait, that didn't make sense. The size of my window that this game takes place in, I'm going to have to change it to the full size of the screen. You'll see I've already done it. It's kind of a necessary evil. Don't love it. But the reason I'm doing it is because it's kind of hard, at least I haven't figured out how, to find where the screen is located, where your window is located in the larger screen. Because the robot class doesn't care about the screen coordinate. The robot class doesn't care about your window coordinates. It cares about the larger screen coordinates. So 0, 0 is literally the top corner of the screen. It doesn't matter how big your window is or where your window is located. It's not relative to the window. It's relative to the entire screen. So, if you're not full screen, then you're kind of getting yourself into trouble because you're going to teleport to the wrong place, and it's just going to be kind of wild. So, I recommend after you do this change, just making your screen the display width and display height. Then when you go to run this, press Command Shift R or Control Shift R if you're on a PC, and then it'll go into full screen mode. It sort of like takes focus over. And I think I'll just run a little bit smoother for you. Like you'd have to Alt Tab to get to something else, but it'll work the best this way. So notice that my mouse kind of scrolls over. When it hits the left-hand side, watch, it's gonna like bloop teleport over to the right-hand side. And if I go the other way, you'll see it works there as well. And this looks fairly smooth right now, but do you see there's a little like bloop? There's a little glitch. Like it's not smooth. It's not perfect. There's a little bit of a jump. And I haven't quite figured out how to get rid of that jump. It's not perfect. It's a little bit glitchy. It's not bad. It's not bad. But it's not perfect. So I'll keep thinking about it. I'll figure out how to make that perfect. But in the meantime, this will be good enough to let you move forward and generally feel like you have reasonable controls. So the first thing to do, I guess it's not the first thing, the next thing to do is to instantiate your robot object. That's a pretty simple line of code, but notice it's in this new structure called a try-catch. It kind of looks like if-else. And the idea is that in a try-catch structure, you try something, and if it generates a runtime error, throws an exception, as they're called, then you can catch it, which is sort of like saying, instead of your program crashing, oh no, there's an announcement.
Just a quick update about use of the cafeteria.
Okay, the cafeteria.
I'd like to thank all the students that have been very helpful and cooperative.
That's great. It's not been easy.
However, I've got a different issue to bring to your attention this morning.
Okay.
We've got a number of students, I'm sure it's only very few, that up. We really do not
Oh
respect
no,
that type of behavior.
that's not
Please
good.
don't
That's
do
stealing.
that. If you are doing that, please stop. It is
Please
very
stop.
disrespectful and does not
Yeah,
fit
stealing
the
is not
of
good.
our school. We know it's only a minority, but please be respectful when you are in the
Okay,
cafeteria.
good announcement. Please don't steal
Also,
from the
unfortunately, after
cafeteria.
school hours, there have been some thefts in the cafeteria, so that area will be locked down by 4 p.m. And it's unfortunate that we have to do that because we
Yes.
know students use that area to study after school hours.
That's unfortunate this happened
We'd
during
like
the
to
video.
ask any students that do have information for us about students that are misusing our school, and particularly in the cafeteria, to please step forward.
Yeah, that's no good.
Thank you, and we appreciate everybody for your efforts to keep us safe and to respect our school
Yes,
at all times.
that's
Thank you.
great. I would record this video, but it's on my like third take, and I'm running out of time, so we're just gonna keep going. So there you go, little message from the principal in the middle of our video. Please don't steal from the cafeteria. I'm sure none of you are doing that. So sorry that we wasted that time. Anyways, so getting back to it, a try-catch structure allows you to respond to an error message. Normally, like what happens when like you have like a null pointer or something, like the program crashes and then there's some error message gets printed inside of the console, right? So now if an error occurs, we can actually catch it almost like an if statement and say like, well, run this code if the error happens. And we're not going to do anything special. Like we're not actually going to use it for anything interesting. This is just exactly what a null pointer exception does. It just prints that to the console, and it doesn't really help us in any way. But it's interesting to know that you could write a way to catch an error if it was caused in the middle of running your program and do something specific. This could help you with debugging, but it could also be a way for your program to like keep running even though it's like crashed and is falling apart, and you could do something more graceful than just like just crash. Anyways, we're not going to do anything with it. We're just going to literally do this to instantiate our robot class. You literally have to instantiate this class inside of a try-catch. It won't let you do it otherwise. So that's why we're going to put that in there. Once you have your robot object, you can use it to control the mouse and keyboard. And here's what we're going to do. I'm going to scroll down to my control camera function. At the very bottom of my control camera function, you'll see I have if-else statement. And basically I say, hey, if I go over to the right-hand side of the screen, if my mouse collides with the right-hand side of the screen, or very close to it, then I'm going to teleport my mouse. Mouse move is the method call. I'm going to teleport it to the left-hand side of the screen. And then just the reverse, hey, if I am hitting the left-hand side of the screen, teleport over to the right side of the screen. You'll notice that I'm doing sort of like 2, or width minus 2, and then I'm teleporting it to 3, or width minus 3. That way, the 3 and the 2, the reason they don't match up is so I don't accidentally collide on the other side. You would think that like with the greater than or less than, I could use 2. Let's just see. Like I think I tried that before, and it's got like shaking back and forth, kind of teleporting back and forth. Let's see. You'll notice when you first start, like the mouse feels like it's not calibrated or something. You have to kind of shake it around to get it to work. It's okay. So I'll move over and like, yeah, I don't know. It doesn't. Oh, maybe I'm not running in full screen. Command Shift R makes this work a lot smoother. So like 0, 0 truly is 0, 0. So let's get back on it. Let's see. I don't know. That worked out okay. I don't know. I can't cause it to make an error, so maybe this is actually better. Maybe make that 2 instead. Anyways, that's the idea. It just kind of teleports you over to the other side. And I'm going to keep working on trying to avoid the error where we have that little kind of gap, that little jump when we shift over. I feel like it shouldn't be that hard, but nothing I've tried has really solved it yet. So I'll just keep working on that. In the meantime, this will get you moving forward, and I think that'll be good. For the next set of videos, we're actually going to be looking at some older videos. There are from a year ago, and they're basically going to help you take a map, a 2D picture, that's sort of like a floor plan, a top-down floor plan, and we're going to use a loop just like we did in the Dungeon Crawl project, and we're going to scan that in using some for loops this time because that's a new fun thing to see. And we're going to scan it in and turn it into a 3D environment. So where there's black pixels, for example, we'll put walls. And when there's white pixels, we'll put nothing. And later on, we'll change that. So instead of like just a random rect, we'll put the textured blocks in, the textured cubes, I should say. So we'll bring in that textured cube stuff from the first part of this project, and we'll merge it with this part of the project, and we'll make a little environment to walk around in. I think it'll be great. Okay, thanks so much, everybody, and we'll see you soon. Oh, wait, I can't turn it off with a shortcut. I have to go over here. I'm having a lot of technical difficulties, folks. Thanks for your patience. Take care.